Hello, everyone. Thanks for joining the webinar. My name is Anand. I'm co-founder of rorodata. So today in this session, I'm going to talk about deploying machine learning applications on DigitalOcean. So this talk is not really about machine learning, but about machine learning in production. So let me get started. Let's get started. I work in the intersection of machine learning and DevOps. I'm a Python expert, co-author of a microversion Python. So I worked in machine learning and also on managing servers. So I kind of have been working for a year and a half trying to build a platform to simplify deploying machine learning applications. And part of that work, we have open source a lot of tools of the framework and which can be used to deploy machine learning applications on your own server. So in this session, I'm going to take you through the tool and explain how it can be used to deploy your machine learning applications onto DigitalOcean. So let me start with a quick introduction to machine learning. I'm sure you all know all of it. So machine learning is a field of study that gives computers the ability to plan without being explicitly programmed. So it just means we don't have to write rules ourselves. Given the data, it kind of figures it out automatically. So if you look at a typical machine learning application, a typical machine learning flow, you have historical data, you train it, and you get a machine learning model. And when you take live data and then give it to the model, that gives you the predictions. So that's how machine learning in a nutshell. But when you go take it to production, it feels a bit different. So what you have is now you've done your training and you have your model. You don't use it in some application. So what you have to do is the best way of doing it is by building an API. So you have to get an API serving the model and then use that in the application. The way it is done this way is the application you're using may not have all the software dependencies that you're required to predict from the model. Also, you don't want to carry on the model all around. So maybe you have an Android application where you want to use the predictions. So what you do is you have an API and then call it from the API. So when you start, it looks like pretty simple. You have a model API and application, but over time, that gets more and more complicated. So over time, what happens is as you grow, you don't have just one model, but you have more and more models. And each model is serving an API, and more than one models are being used in a single application. And over time, you actually have multiple versions of these models, and it kind of becomes like non-trivial task to kind of manage these kind of things. So unless you have some kind of tools to help you manage these things, it's going to become a bit very unproductive to manage these things. So with that introduction, let me take you to like what we're going to do today. So we're going to build a sample application. So this is a deep learning application. What it does is, given any image, it removes the background and gives the new image. Now, for this example, I'm not going to build a model myself, but I'm going to use a model developed by someone. So the important part here is, once you have the model, how do you take it to production? How do you build an application which is using that model? So that's what we're trying to achieve it. So what happens is, in this application, when you click on any of the image or add your own image, it sends the image to the API, and then the API uses the machine learning model to predict a new image, and that's sent back and that's displayed in the application. So we have all this complex back and forth going on. So user clicks in the application sends the image URL to the API, and API uses the model to do some inference and then sends the new image data back, and that's displayed in the web app. So what we're trying to do is to what all it does it take to actually build this kind of applications. So that's what we're going to do. So let me kind of explain the key elements that are there when you're doing a machine learning in production. So one thing is, you want to kind of build your application, so build your models and build your APIs and all that. And once you've built all the stuff, so for building the machine learning models, you need to have a server where you have install all the software, and then once you build the model, you have to deploy that as an API. So the deploying part, so you have to figure out how to deploy it. And also you have multiple models. You have to figure out how to manage all of them, and also figure out how to monitor them in runtime. So for this session, I'm going to focus only on the build and deploy part of it, and not really go into the manage and monitor part of it. So we'll see how to build these models and how to deploy them. So those are the key focus areas we're going to look at in this session. So let's look at the challenges in each one of these things. When you want to build things, what you typically do is you typically start your training with a smaller data set. Once the result starts looking good, you train it on a bigger data set. So it's good to have switching between different compute needs seamlessly, but you're working on not that big data sets, that's probably not an issue. But often the very painful thing is to figure out how do you set up the software dependencies. Excuse me. So you may be working with Keras or version 2.0 or 1.9, whatever version that you're using. So how do you install software dependencies on the server that you are working on? So that's usually the challenge. A lot of times you also want to automate some of the things by retraining models periodically. So you put the new data in somewhere, and then a script should automatically run and then pick the new data and then build a new model and then move that to production. So that would be, these are the kind of challenges in building these things. Assuming that we have that thing solved, deploying again is a bigger challenge, because we have a machine learning model sitting in a file somewhere, but how do you deploy that as an API? Now, there are multiple ways of doing it. Often people write a web application for doing it. So what happens is once you start building these kind of applications for APIs, you'll have a lot of different APIs almost doing the same things, but each one is slightly different. So you end up writing different client library for each one of them. And there are also common tasks between these APIs, like providing authentication, etc. So it's useful to have some kind of framework for solving these kind of things rather than building applications for each model that you want to serve. Also, even if you have an application for deploying with an API, you have to figure out how you're actually going to put it on a server, and then on what port you're going to run, on what domain you're going to expose that, and all those kind of things. So while these endpoints is again a non-trivial task. Also, when you're running a service, you want to make sure that the service doesn't go down. So what you typically do is you put some kind of supervisor. What it does is make sure that the service is always running. If it fails for whatever reason, it tries to restart it automatically and all those kind of things. So these are the challenges that they're in deploying applications. So the thing is now, when you're looking at building machine learning applications, we're talking about a data scientist trying to do these kind of things. So the data scientist may not have the skill set required to actually do these things manually. And also, even if he has that skill set, maybe he's really not interested to do those kind of things at this point, because he's really keen on deploying this. The work at hand is deploying the applications, not really configuring servers, etc. So the way typically it's done is people use like a bunch of tools. People use Ansible, Supervisor, Fabric, Docker, Kubernetes, Nginx, whatnot. Okay, so you search for how to deploy machine learning applications in Google, and you actually find a lot of people talking about bigger blog posts about how do you do all these things using all these tools. The thing is, it's possible to do with all these tools, but the thing is, do you really want to spend time tweaking these kind of tools every time you want to deploy machine learning applications? Probably not, right? So the key thing is to figure out what's the right level of abstraction. So what we're trying to do now is to see use a tool called rorolite, which is an open source command line tool for deploying machine learning applications on your own server. This light version of the rorodata platform, which is a PaaS platform which provides the similar capabilities in the cloud. So let's see how to kind of use rorolite and how it actually works. So let's look at how to install it. So you just have to pip install rorolite. That is a Python library, and that installs on your computer. So you do this on your computer, not on the server. The way it works is you always work on your own computer. So you work on your laptop. So you install rorolite on your laptop, and then you have a remote server. You take a droplet on DigitalOcean, and then you run your rorolite commands on your local computer, and it sends commands to the remote server and then get stuff done on the remote server. So you don't really have to do anything on the remote server. All you have to do is find out what's the host name and IP address of the remote server and give the credentials in a config file. So one thing to remember is that rorolite currently supports Ubuntu 16.04, the LTS version of Ubuntu. That's required on the remote server. But on your laptop or your computer, you can use anything that you want. You can have Linux, Mac, Windows, whatever. That doesn't matter. So that's how that works. Okay. So the way it works is, let's look at a sample project, how it looks like. So I have a project called background removal, the one we're going to use in the demo as well. So it has all these files. There's a background removal.py, which is the actual code for doing background removal. And then there's a requirement.txt. These are the application dependencies. So if excuse me, the application may need special libraries to be used. So those are specified in requirements.txt. And then there's a rorolite.yml. There's a config file that specifies everything about what needs to go into the server. In this particular case, I don't have any training because I'm using a model downloaded from web. Let me look at what goes into rorolite.yml. So this is the key part of the key abstraction of rorolite, okay, or even the same ideas I've taken from the rorolite platform. So what we specify is what's the base runtime that you want to use. So want to start from Python 3 Keras. So that installs all the libraries required system-wide. And then you specify what's your host name and what's the username that you want to connect to. And then you specify what services that you want to run on the server. So what rorolite allows you to do is to specify a Python function to be exposed as an API. So all you have to do is write a Python function. That's it, nothing else. Okay, it takes care of everything for you. And you specify what's the name of that and at what port you want to expose that. Now, let's take a closer look at what runtimes are. Runtimes takes care of all software that needs to go into installing in the system. This includes the system packages and the standard Python package that goes along with that. So we have like 3 runtimes available right now. It's Python 3 that includes scikit-learn, NumPy, etc. Python 3 Keras that includes everything of Python 3 plus TensorFlow, Keras, and OpenCV. And we also have an experimental Python 3 Keras for Raspberry Pi. So if you want to install, deploy machine learning application on Raspberry Pi to be used wherever, that could be used as well. So the way it works is you start with provisioning. So the server needs to be provisioned once. You don't have to do it again and again. So once you start the server and you say run rorolite provision, so what it does is it looks at the runtime and then goes and installs all the required software on the server. This has to be done only once. Once that is done, you have your code ready and so when you do a deploy, it installs the application specific dependencies and then starts all the services at the port that is specified. Now, the deploy is something that you may want to do it again and again because you deploy once and you want to make some code changes and then you deploy again. So that sends all the code from your current directory to the remote server and then installs all the Python dependencies. Again, the application specific dependencies, not the ones present in the runtime. And then restarts the services. Now, it also allows you to run different programs on the remote server, but you don't have to really log into the remote server for doing that. All you can do is you can say rorolite run and then say Python train.py. You have a train.py that runs the train.py on the remote server. Or if you want to run a notebook, you say rorolite run : notebook that starts a notebook for you. So that's how rorolite works. Okay, so now what I'm going to do is to show a demo of how actually it works. So let me take you through a demo. Okay. So what I'm going to do is to actually go here, DigitalOcean, and I'm going to create a new droplet right now. So droplets. It's going to create Ubuntu 16.04. Let me do it in Singapore region. I'll add my SH key here. I'll call this rorolite demo. I've created a server. So this is creating a server now. Let me actually also go and add a DNS entry for this. I have a domain that's hosted here. So I'll add a new entry here, rorolite demo, and I'll attach that resource here. So what I've done now is I've created a new server and also a host name for that. So let me try if I can actually log into that. That should allow me to log in. It's probably taking a while. Oops. Okay. I guess it's ready now. Yeah, so the server is ready. Okay. Now what we need to do is, like I mentioned, so the project is rorolite demo. So what I have here is an YAML file that contains a runtime. What's a host? So it should be rorolite demo because the new server I've created is called rorolite demo. Username is root. And then let's only look at the API part, and this I'll basically comment out for now. Okay, so this is the API. This is exposing the background removal.predict. So let's spend some time looking at the code and understand what this thing is actually doing. So the predict function here, it takes an image as an argument. It's actually a dictionary containing the URL. And then it reads an image. So when you read an image, what it does is it accepts either the basic square encoded data or an URL. So if you send an URL, it gets the contents and then creates an image and then sends the actual image back. So what the predict1 function does is it takes a NumPy array of image as a NumPy array and then gives the new array here. So what it does is it takes a NumPy array of image and then removes the background and gives a new image array, and we write that image back. So you get back a JSON containing a basic store encoded image. So let's see what the predict what this function is doing. It takes image, resizes and all that, okay. And then so there's some computation going on about how do you actually build the image, but if you actually see the ML predict function, it's loading the model in the beginning. So in the beginning, it downloads the model. So if the model is not there, it downloads it and then loads the model. And then the ML predict function uses that to predict the new image. So this is a deep learning prediction. So we're really not really worried about about the algorithm of the deep learning here, but how actually the deployment process works. Okay. Now, given that this prediction actually works, let's see how to deploy this in API. So we have specified that this is a runtime. This is a server where I want to actually install it. Okay. This is a fresh new server that I've just created right now, and I want to deploy this. So first thing I need to do is to kind of provision the server. So rorolite provision. So it's going to the remote server, and then it's going to install everything that's required to be installed on the server. It's going to take a couple of minutes because it's going to download a bunch of system packages and then Python packages like TensorFlow, Keras, and all those things. Let's see how long it takes. So while let's wait for like a couple of minutes. So that's installing the packages. While it's happening, let me kind of show the application what we're going to actually deploy. So I've already deployed it as an rorolite to. So this is the application we're actually trying to deploy. So you click on, so this actually I've deployed on another server just before the session starts so that I can actually show you this live while that's going on. So you click on an image, it sends the image back to the server, and then it takes about 10 to 15 seconds for the inference to happen. Yeah, so it removed the image, okay. It removed the background and then gave the new image here. So this is the application that we're trying to build, okay. Now, let's actually try and actually see how it actually works, okay. So what we are doing, using here is the platform takes a function as an argument here and then actually deploys that as a service. So what it does is it behind the scenes, it uses a library called Firefly, which is again, an open source tool from the platform. So what this does is you write a function here and then say Firefly module name function name that starts running as an API, and it takes care of doing all the JSON serialization and all that. So let's see how far we have come with the demo, with the provisioning part. So it has installed all the system packages required, and then now it's installing the Python packages. So I guess it's going to take a while. While that's happening, let's look at sorry, rorolite. While that's going on, I'll show you how this thing is actually working. So rorolite. So here I'm using the rorolite 2 server here. So if I see here, there is a the code, there is a test.py. So what this does is it finds hostname and port name from the rorolite YAML file, and then the way it works is it provides a client library by default. So all you have to do is create a client, and then so Firefly client gives you a client that you can actually use. So it feels like an RPC call. So you have an API, which is an handle to the actual API out there. So what we're doing here is passing the image URL to the API.predict. So the way it works is it feels like a module in Python. So there's a function called predict remotely on the server. So we're trying to call the predict function locally through the API client. That gives a response which contains image bytes. We're writing into an output file here. Let's try running that here. So I think it has a default image here. So Python test.py that would actually send a request, call the background remote API, and then save as the output here. Let's see where we are with the provisioning part here. So it has actually provisioned the server and everything else is set up there now. Now, what you can do is you can say rorolite, run any commands there. You can say rorolite run, let's say date. So what's the date on the remote server? Okay, so it will go there and then runs whatever you specify. Okay, sorry, we have not deployed anything now. So that's looking for the directory. So let's deploy it once. So the deploy, what it does is it takes all the code, sends it to the server first. So it makes, it's the first version. So it's creating a zip of entire project, sending it to the server. And then whatever services that we specify here, you see in the role, we have only one service. So what it'll do is it'll create required config files on the server, sends it there, and then installs all the Python dependencies there for the application, and then starts those services. So let's see how that actually works. Well, this would have been done now. Okay, so what it did is it called the API with an image, and then it's the API, it's the image that we have got it through the API. Okay, So let's see what it's doing. It's installed. It's installed the Python dependencies. And then, okay, it says this is a URL where the new API is live. Okay, let's see if we actually have the API. I think here it seems to be not there. Okay, let's see what's going wrong. Okay, so you can say rorolite logs and API. So what it does is each service has a name, and then there's URL endpoint, and you can actually, so rorolite takes care of configuring the logs and all that. You can look at rorolite logs and then give the name. So what it does, it shows the last few entries in the log. So actually what was happening was, since we were doing it the first time, it was downloaded the model. That's why it took a while to start the API. So it would have been ready by now. Let's see. Okay. Strange. Yeah, it's ready now. Okay. So what it's giving is it's giving some metadata about the API. So it tells you what all functions are there in the API, and then what all arguments it takes, etc. Now you should be able to actually use this API. Now, to understand it better, what I want to actually do is to actually add a simple API so that we actually understand how that thing works, and then try to understand that better. So I wrote a simple file called square.py here. It just takes a simple square function, it takes number and then computes square of that number. Now what I'm going to do is to deploy that as an API. So what I'm going to do is here, call it square, call it run 8090 sq.square. Okay. Now let me also do this one, which is so I have a simple one HTML page for displaying using the API. So I'll deploy all of these things now and see what happens now. So it's going to deploy all three services now, which we'll be able to use once the deploy is complete. Again, it's setting up a new virtual environment here. So it has already copied all the required files, setting a virtual environment, installing the Python dependencies required for the application. Again, remember that these are not dependencies which comes with the runtime. So if you say Python 3 keras, the keras is installed system-wide. So that you don't have to install every time. So let's see. I think it's going to take half a minute or so. So the beautiful thing about this is you don't really have to worry about anything on the server. You just have to run a command locally that logs into the machine and then does everything required there. Okay, and then it gave all the API endpoints, all the services. It's running 3 services now. You can actually look at rorolite PS and see what are the services that are actually running. So behind the scenes, it's actually running a tool called Supervisor, which is running all the services. And if something goes down, it automatically restarts it and all that. Now, since we have deployed a simple service called Square, let's try to understand how actually that service works. Okay, so I'm running Python locally on my machine. So Firefly is a library that is used to connect to the services. So Firefly is a building block of these services. So I'm going to create a Square service. So Square API would be firefly.client, and then instead of give this this URL endpoint here. Okay, now I can just say API.square and equal to 4. So it actually sends a request to the server and then executes a function Square on the remote server and then giving back the response 16 here. So the nice thing about Firefly is it tries to hide a lot of complexity that you really don't want to worry about very nicely. So what it does is the client actually gives you an interface of a function. So it's as if you actually have a function running locally. Right? So you're calling, it's like if you have to do it locally from a local module, all you have to do is import Square, sq.square and equal to 4. The same thing, so the remote call is actually pretty close to that, but it's actually going over the wire to the remote server and then coming back from there. So that's how the API works. Okay. Now that we actually also deployed a web application, so let's see what then web application. So I'm running a simple HTTP server Python HTTP server in the web directory on port 8000. So let's see what we have in the web directory. That's index.html. So it does a bunch of, it's a simple HTML file which is calling an API through some JavaScript. So I don't want to go into the details of what's in the HTML file, but let's see how the platform works. So this is running at port, web is running at port 8000. So let me go to port 8000. So that would have the background removal app there. So let me actually open a debug console so that actually show all the network that's actually going here. So let me click on network. Okay. So if I click on this, what happens is it's actually sending a predict request to see here. It's sending it to 8080 because what it does is the index.html looks at the current host name, replaces the port with 8080. And makes an API call. So it's waiting for the predict to complete. So let's see how long it takes. It takes about 12 to 13 seconds. Yeah, it took about 16 seconds. Okay, it removed the background and then gave it back. Okay, but if you see, it's all running on the new server that we have provisioned right like 10 minutes ago, and then we've deployed the code and it's running here. Now, you can also add a new URL. For example, I don't think I have an image handy, but you can even give, let me see if I actually have. So I have an image of myself speaking. Want to see if this can remove the background of that. So I'll give URL here. So that's sending URL back. So let's actually see how the API call actually looks like. So what it's, I think let's do the previous one. So let's look at the, yeah, I think this thing has come out. Okay. It's a response. The request data is basically sending an image, and this is the URL of the image. So this is what's sent to the API. So API takes that URL from there and then downloads the image, and then applies the machine learning model, and then gives back the results. So that's how the deployment is done. Again, the important thing is you can actually use Firefly client to actually use the API without having to worry about what parameters it takes and all that. The nice thing about it is actually it really feels like a local function, because the Firefly tries to make it like a local function. I'm sorry, I have imported Firefly. Now I can say SQ API.square. Get help on that. It actually shows that it's a square function, complete square. It's actually doxing is coming from the remote server, because we don't have square function here. It's coming from the square API. So what it does, it sends all the documentation and all that here, so that it actually feels like a local function. So whenever you want to use an API, you just have to import the client, create a client, and then start using the same function as if it is available locally. Now, let me summarize what we've seen here. So the rorolite, what it does is it takes care of the setup seamlessly. You don't have to really log into the server and set up and figure out what all needs to be done and all that. Okay, so there is a seamless setup it comes with. Okay, and also still it's not there in the current version, but there's plans to actually set up flexible scheduling where you can actually specify that I want to run this job every time at 10 a.m. or something in the rorolite.yml file itself, and then that would automatically set up whatever is required on the server. And it takes care of functions as API, and also take care of running the services. Okay, so if you're in early stage with your machine learning thing and you want to actually try running your machine learning application on your own server, I think it's pretty good start. So it takes care of everything from provisioning server to deploying an API so that you can actually start using it. But as you actually scale out, you may want to do more things. For example, if your data size is pretty big, you may want to actually start training on a smaller set, but you want to run a bigger data set training on a larger instance and all that. So you require more and more tools, and that's where cloud platform like rorodata platform kind of helps. So the platform is actually, rorolite is actually taken from the APIs or the interfaces that are developed for the rorodata platform. So in addition to what rorolite offers, what platform does is, since it's not tied to a single computer, since it's in the cloud, it allows you to run jobs on different instance sizes. What you can do is you can actually try a training algorithm on a smaller instance. Once you feel comfortable, you can actually run the same thing on a different, bigger instance or on a GPU, etc. Since it's a platform, it automatically manages domain names for you, automatic endpoints. The thing is, right now we're working on ports. We're specifying what port service should run on. So what the platform takes care about it is it takes care of managing all those things behind the scenes. It also takes care about managing multiple versions of models and then some performance monitoring and all those kind of things. Okay, but so rorolite is good enough if you want to deploy smaller models with you, but if you want to actually scale out or something like platform would be useful. Again, so all the tools that we've described here, except the platform, are open source. Rorolite is an open source tool for deploying machine learning applications. What we have seen the demo of today is available at this URL. The Firefly is again open source, that's available at this URL, and the demo that we used again is also open source and available at these URLs. And thanks, and open for questions. If you have, if you want to reach out, if you have any questions about deployment or something, you can always reach out to me at Anand on Twitter.